Good morning and welcome once again to my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho, and we continue to explain Pure Mathematics 3, topic number 6 and example 4, and on page 126. And in this video, I want us to apply the standard results of some differentials, some very important and critical differentials, to explain example 4. And we know, we have heard previously, that if y is equals to e raised to power kx, dy dx is equals to k e raised to power kx. And if y is equals to ln x, or natural logarithm of x, then dy dx is equals to 1 over x. And if y is equals to a raised to power kx, then dy dx is equals to the same term a kx multiplied by the constant k ln a. So we are going to use this to explain what is in example 4 on page 126 of Pure Mathematics 3 of International Advanced Level. And this is actually example 5.4. We have explained example 4 in the previous video, so let's go to example 5. Find dy dx given that part A, y is equals to e raised to power 3x plus 2 raised to power 3x. And of course, we need first of all now to understand what among these standard results, which one among these standard results are we going to use here. And of course, we are going to differentiate polynomially, or rather term after the other. This gives us our dy dx, or rather differential. If you look at this first term, is in the first format, whereby the dy dx is k e raised to power x. So it goes without saying our k is 3. So we have 3 multiplied by e raised to power 3x, and that is it. Plus, if you look at this one, it's already in the form of it's already in the because 2 raised to power 3x, we have this one is already in what format? In this format, in the last format, whereby we have a, which is our 2, our a is 2, and our k is 3, and x remains x. So the dy dx of this is the same thing what was originally there, which means 2 raised to power 3x multiplied by the value of k, which is multiplied by 3, and then ln 3 ln 2, because our a is 2. So we have it like this is simply 2 raised to power 3x multiplied by 3 ln 2. Remember, you have to be very sure there. This second term is in the third format. This third format, where a raised to power kx, and our a happens to be 2, our k happens to be 3, and x remains x. So the dy dx is given by a kx, which means a kx, the same thing that we had here, multiplied by k, which is our 3, ln a, and our a is 2, ln 2. And that is the end of it. If you could simplify further, then that would be awesome. But with this, I think we are good to go. Part B of the expression, what we are having now is y is equals to ln x cubed plus ln 7x. And of course, we just have to apply the laws of logarithm here so that we can free up these terms. And ln is, of course, log to base e of this, and x is cubed. So it follows that y is equals to 3 ln x, because the index now becomes a coefficient, plus ln x times 7. And of course, you know, the way we know, the logarithm of ab is the same as the log of a plus the log of b separately, whatever the base. And this base is log to base e, and that's why we are calling it ln. So the ln of x plus the ln of 7 plus the ln of x, using this law. And at that point, we can probably collect the like terms, and we're going to have y is equals to 3 ln x plus ln x, which is 4 ln x plus ln 7. And of course, dy dx now becomes 4, and because it's a constant, the differential of ln x is simply 1 over x. So we multiply by that, plus what is the ln of 7. The differential of ln 7, the differential of ln 7 is simply, let's see that, the differential of ln 7 is 0. Of course, you talk about, use the standard result for ln x. In ln 7 is a constant, so it disappears when you differentiate. But because ln 7 is a constant, you would treat it like a constant. This one is a constant, and once you differentiate a constant, of course it disappears. But the reason why ln x is having a differential of 1 over x is because x itself is a variable, and this is not a constant because x is a variable. And you know what? We are differentiating this function with respect to x, so there is no way this one can die or can be 0. And therefore, for that reason, the differential of ln 7, which is a constant, is 0. And of course, we end up having the differential to be 4 over x. That is as far as part B of the expression is concerned. It is very important that you note this, as I've explained. Let's go to part C. Let's go to part C. And part C is y is equals to 2 minus 3e raised to power 7x, everything over 4e raised to power 3x. And of course, because the two numerators share the denominator, let us separate the terms and have 2 over 4e3x minus 3e7x over 4e3x. And according to the laws of indices, all this will, this one is going to be a half, 1 over 2, 1 over 2. And then because we cannot differentiate with respect to x, when it is at the denominator position, this one has to go up there. So we have e raised to power minus 3x minus 3 over 4 multiplied by the same thing, e raised to power 7x minus 3x, which is e raised to power 4x. So if you clean up this a little bit here, we are going to have something that looks like y is equals to e raised to power minus 3x over 2 minus 3e raised to power 4x over 4. That is exactly what we are having. And now the dy dx of this, when we differentiate this one is already the constant is a half, so we have a half is equals to, there's a constant half here, so a half multiplied by or times, there is a negative k which is minus 3, and the differential of this e is e raised to the power minus kx, which is 3x. What about the other one? The other one is the constant is still 3 over 4, so minus 3 over 4 multiplied by 4, because these constants come over there. This constant now, there's a constant here which is k. K multiplies out, and then we remain with e raised to power 4x, the same thing that we had. And if we clean up this one, dy dx becomes minus 3 over 2 e raised to power minus 3x. Of course, minus 3 over 4 times 4 is minus a 3 e raised to power 4x. And that is just like it. So we have been able to differentiate the three statement. That is the end of it. So please make sure that of most importance are these standard results. And the moment you understand them, then there is no differential of logarithm or exponential that will be difficult to you. So yes, again, visit my YouTube channel, Pearson Edexcel International Math by Mr. Kamotho. Of course, subscribe, share widely, and like, and let's work together as we succeed.